Hello, everyone, and welcome to the Data AI Express, your ultimate guide to data and AI. In our Ultimate Guide series, we have been exploring various technologies. Today, we are diving deep into data architecture part 2. If you missed part 1, I highly recommend watching it. We covered the fundamentals of data architecture, its key principle, and evolution of data. We also discussed OLTP versus OLAP and took a deep dive into data warehouse, data lake, and lakehouses. These foundations will help you to get started. So today on building on the part 1, we will now explore various data architecture patterns, including Inmon versus Kimball, data pipelines, ETL versus ELT, layered and medallion architectures, and innovative concepts like Lambda and Kappa architecture. We will also cover monolithic versus microservice approaches and crucial data modeling concepts like star schema, Snowflake schema, data vault, anchor modeling. We will even touch upon cutting edge topics like graph databases and data fabric. These are the countless architectural patterns and strategies to explore. So let's get started. This is Data Express. Once again, I welcome you for exploring data architecture. The two pioneers, Inmon and Kimball. When you think of data architecture, two names should immediately come to your mind. One is Bill Inmon and another one is Ralph Kimball. They proposed two distinct approaches to build a data warehouse. Bill Inmon, often called the father of data warehouses, championed a top-down approach. He argued that you should first build a centralized data warehouse. This method ensured data integrity by eliminating redundancy and normalizing the data typically to the third normal form. Once a warehouse is built, you can then create specific data marts for different departments and generate OLAP reports. This approach is comprehensive but requires significant upfront investment and alignment across all business teams. On the other hand, Rolf Kimball proposed a bottom-up approach. He suggests starting with a smaller, more focused data marts. This is ideal when only a subset of the businesses, like the finance department, is ready to start. You can build a data mart for them, provide its value, then scale out to other departments. This agile, small scale start allows you to demonstrate a return on investment ROI before committing to the full scale data warehouse. Data pipeline, ETL and ELT. No matter which approach you choose, you will need a data pipeline to load your data. A data pipeline is a series of automated steps that move a data from a source to a destination. This process involves collecting, ingesting, preparing, and processing the data, and then processing it into a usable format. This is all managed by a job that can be triggered by an event or run on a schedule. This job connects to the data sources, pulls the eligible data, process it, and then loads into the target system. There are two primary methods on this: ETL, extract, transform, load, and ELT, extract, load, and transform. In the traditional ETL approach, you first extract the data from the sources, then transform it using tools like Informatica or Talent, and finally load it into the destination. The transformation steps requires a powerful engine with significant CPU and RAM to process the data before loading it into the on-premises databases like Teradata or Oracle. The alternative approach is ELT, which is a cloud-native method. You first extract the data, then immediately load into the cloud data lake or S3 or ADLS. The transformation happens after the data is already loaded into the cloud. This approach is most cost effective for the cloud environment because it minimizes the data transfer cost, because in cloud, egress and ingress are cost more. Architectural patterns, layered and medallion. When building your data architecture, you can choose between a 3-tier architecture or more modern medallion architecture. The classic 3-tier architecture separates the application layer, the business logic layer, and the database layer. This creates distinct layered data sources and stages. To access the data, you have to go through the front end. In contrast, Medallion architecture, a layered approach popular in the cloud, continuously loads data through batch or streaming process. The data flows through different layers like bronze, which is a raw data, silver, cleanse and filter data, and gold, aggregated data ready for business consumption. This architecture ensures that data is always available, that the system is decoupled, meaning a large job is one layer won't close downturn in another layer. This is why it's popular choice for the cloud-based data platforms. Real-time data processing, Lambda and Kappa architecture. For processing real-time data, you can either a Lambda or a Kappa architecture. The Lambda architecture uses two separate paths for processing, a batch layer for historical data and a speed layer for real-time data. This allows you to get immediate insights from real-time data while still being able to process a large batch of historical data. The Kappa architecture simplifies this by using a single stream processing engine for both real and historical data processing. This eliminates the need to manage two separate pipelines, making the system easier to maintain and ensuring the data is always processed in real time. Monolithic and microservices. Traditionally, applications were built using monolithic architecture with a single database and a single code base. However, this approach has limitation in terms of scalability and concurrency. The modern solution is a microservice architecture. In this architecture, the application is broken down into smaller independent services, each with its own databases. These services communicate with each other through APIs. This allows you to scale each service independently, making the system more resilient and easier to update. As a data engineer, understanding microservices is crucial. Let's look at the data modeling concepts. Let's talk about how to store a data within your architecture. This is where the data modeling comes in. In data modeling, a table is called an entity and the columns are called attributes. Each table has a primary key that uniquely identify each rows. We also define relationship between the tables such as one-to-one, one-to-many, or many-to-many. Normalization is the process of organizing the data to reduce redundancy. The most common forms are the first, second, and third normal forms. In contrast, denormalization is the process of adding redundant data to improve the query performance. This is common in cloud databases where you have unstructured and semi-structured data. Two of the most important data modeling concepts are star schema and the Snowflake schema. In the star schema, you have a central fact table which is surrounded by a dimensional tables. The fact table contains the quantitative data, while the dimension table contains the descriptive data. A Snowflake schema is an extension of the star schema, where the dimension tables are further normalized into multiple related tables. We also have slowly changing dimensions, which is also used to track the changes to the dimension attributes over the time. There are SED type 1, type 2, type 3, and so on. Modern data architecture. In modern data architecture, we have more advanced modeling techniques like Data Vault 2.0 and Anchor modeling. Data Vault 2.0 uses models of hubs, links, satellites to provide a flexible and auditable data warehouses. Anchor modeling is a highly flexible and agile data modeling technique that is well suited for environments where data requirements are consistently changing. Graph databases are another important modeling technique, especially for data with complex relationships. They use nodes and edges to represent the data and their connections. Finally, we have the concepts of data mesh and data fabric. A data mesh is a decentralized approach of data architecture where data is treated as a product and owned by different domain teams, which is now heavily adopted in all the enterprises. A data fabric is more centralized approach to use metadata to connect all the organization data regardless of where it is stored. A key concept within the data fabric is data virtualization, which allows you to query the data from multiple sources without having to move it. Example tool is Denodo. Choosing the right databases. With so many options, how do you choose the right databases? For transactional system, you will want a SQL database, OLTP. For analytic systems, you definitely need an OLAP database. For unstructured or semi-structured data, a data lake is a good choice. For multi-domain system, a data mesh or a data fabric can be considered. For rapidly changing data with high variety, a NoSQL database is a good choice. And for generative AI and RAG application, a vector database is ideal. When choosing a database, you also need to consider things like indexing, partitioning, compression, and query optimization. The future of data architecture. Looking ahead, the future of data architecture is cloud native, real time, and AI driven. You need to be thinking about how to integrate machine learning and AI into your data architecture, how to ensure a security by design, how to optimize for cost. Let me give you some case study, a real world example of what can go wrong. There is a launch of healthcare.gov website in 2013. The site crashed on the first day because of the architecture was not designed to handle the high volume of data traffic. Another example is the Night Capital trading error in 2012, where a software glitch caused the company to lose nearly $440 million in just 45 minutes. These examples highlight the importance of proper testing, data quality checks, and a robust, scalable architecture. So, what are the key takeaways? First, there is no one size fits all architecture. This right architecture depends on your specific needs and challenges. Second, always start with business requirement and plan for scale. Third, prioritize the data quality over quantity. And finally, design a system that is future proof, fail safe, and flexible. Okay, everyone. That's a comprehensive overview of data architectures. We have covered a lot of ground from foundational concept to the latest trends. I hope this has given you a complete understanding of the data architecture topic. You can refer this video for your upcoming interviews. If you would like me to do a deep dive on any specific of these topics, please let me know in the comments below. I will connect with you in another interesting topic in the next video. Until next time, this is Data AI Express signing off. Thank you, everyone.